Good morning all and welcome back to the second video of this series on how to build a thermocouple data logger. In this video I will be covering how I choose the components for my circuits. And the first thing to notice here is when I need to do something, I always search first of all application notes from the big companies, okay? Like Texas Instruments, Maxim, Dallas Technologies and so on. These companies provide these nice application notes or application reports where they explain in detail the issue of doing a measurement, and they also provide a nice design for reference circuits and so on, okay? I will link this document in the description of the video. Here there is a much more detailed and accurate description of what I introduced in the first video of this series. So you will see the problems that we have seen, how the peak voltage works, how the different thermocouples are composed and their response. But also you have more in-depth details on how to build a circuit to measure these kind of devices. I'm just scrolling down. Okay, so you have all the notes on how to design a circuit for this and all the problem you can have. And here at the very bottom you have, you see, thermocouple measurement with pull-up and pull-down bias resistor. You have design circuits, so you can use these as reference. But I do not want to get things too much complicated, so I went for an already existing IC, that is the MAX31855. This is a cold junction compensated thermocouple to digital converted, and this, guys, is black magic. So you have integrated circuits that performs all the operation needed to convert the thermocouple voltage into a digital value of temperature independently from other external components, okay? You just need to provide a power supply here, protect the power supply with a small capacitor, okay, like you always do with integrated circuits, I would say, and you can connect directly the thermocouple. Actually, you will need another small capacitor here for, let's say, clean up the noise, okay? And if you want to have more accurate measurement, there are also other things you can do, but basically you will just need two capacitors here. And then you will need a microcontroller that is able to talk in SPI to the MAX31855 and to get the information from the circuit, okay? Let's just look a little bit more in detail this document. I will also link this one in the description of the video, so you can see all this document and see what I'm explaining to you. First thing we notice is that this one is a 3.3 volt IC. So it will not be compatible with 5 volt devices, like for example the Arduino Uno that works in 5 volt. So we will have to be aware of this when we choose the microcontroller. Then you see that the IC is thermocouple specific. So when you buy this component, you must be aware that the last letter of the name here will be related to the specific thermocouple that this circuit can measure. There are other components from Maxim integrated that are also compatible with different kind of thermocouples. We will not use it now here, but maybe in the future, if you like, I will show you also that kind of IC. I have the MAX31855 thermocouple type, and I will be using this one for this project. Then, let's see, serial interfaces. Okay, how this device give the information, so how this device works. Okay, let's skip for a moment the detailed description of the communication protocol and all the characteristics, and I will show you this one that is very interesting. Well, of course, the pinout, and you see you just need 3 pins here to communicate. Here you will connect the thermocouple, and then you have ground and power supply. Inside this circuit we have this kind of block diagram. So when you connect the thermocouple, the system will amplify the voltage, and we have seen that this is needed because we are talking about microvolts. but also have other nice features. For example, it has fault detection and ground detection. What does this mean? The system is able to tell you if the thermocouple is not connected, if the thermocouple is shorted to ground or shorted to the power supply of the IC. And this is a very cool feature because you will know when you have a fault in your system. Then you have cold junction compensation. The IC have an internal sensor and is able to automatically compensate the junction temperature here. All the data are read through an analog to digital converter, of course, and then we have a digital control interface that is in charge of transmitting the data to the host that is connected here, so the microcontroller. There is a nice description on how everything works. It is basically what I just told you, okay? And now let's dig into the serial interface. This device will need an SPI controller and will send the data in this format here. So you will need 32 bits transmission, and we will see later when we will write the firmware for this that we will need to make 4 full receive, because usually the SPI receive of the microcontroller we are using is 8-bit, okay? So we will do 4 consecutive receiving, and inside these 32 bits there are a lot of information. The first 3 bits indicates if the system is open circuit, short to ground or short to power supply. Then we have the internal temperature data of the IC, and here you can read what is the temperature of your IC. Then the IC uses this automatically to convert the thermocouple temperature data that are stored from the most significant bit here, the D31 to D18, okay? And then they also show you how to convert the data. This is very easy actually, and you just have to, when you compose the binary number correctly, you just have to multiply by 0.25 or 0.0625, I think. I will verify later, but we will see this in firmware. So it's very easy to convert the data. You have here, if I remember correctly, well, there are also some circuit design advices here, and they are basically used to reduce noise. So I told you we need a capacitor between the two thermocouple inputs. Then for the microcontroller I will be using, I choose this Adaruit Feather M0 Adalogger because, well, it is such a wonderful device. It's super easy to use. It has everything already built in. This is a Cortex microcontroller, so it is very powerful in terms of speed, much more than a regular Arduino. It has the microSD card already installed, and since the Cortex microcontroller are very cool, there is no need of much more hardware here. The microcontroller uses directly write to the microSD, and everything is built in. And then the coolest feature of all, you can directly connect a LiPo battery cell here, okay, and the system have an built-in battery charger controller. So if the battery goes below the minimum level, or if you want to recharge the battery, everything is managed inside. When you connect the micro USB connector here, the system charges the LiPo battery automatically, and when the voltage of the LiPo battery drops below the safety level, it just disconnects the system. When you connect the USB, the controller switches automatically the power supply, so you can let it plugged in, and when you just unplug the system, you will not have any loss of data or anything. Adaruit is a great supplier. They have a lot of wonderful hardware. It's very well documented, and they also provide very good libraries to use them, okay? So I will give you the link for this in the description, and then we will go more in deep when we will program this IC, okay? So Thank you for watching. If you liked, share, subscribe, and I will see you on the next video of this series. Bye!